Hi, the purpose of this is I'm going to go over a lot of the problem set for Target 4-3. I'm going to show you how I arrive at the solutions, and what you can do is hopefully maybe just fast forward through the video and find the formula that you're struggling with. I will do, I'll do every other one of them, starting with aluminum cyanide. And so yeah, just I'll do 2, 4, 6, 8, and so forth. So yeah, hopefully you can just fast forward and find it. Even though you do have the solutions flipped upside down here, but that might not, you might not know how I got those. All right, so to do this, I'm going to need the problem set. I'm going to need a placemat. Specifically, I'm looking at the official list of ions, the positive and negative ions on here. And let me go ahead and do it. Let's do, well, you know what? I'm thinking about this. Let me just go ahead, I'll do the first one, chromium chlorate. I kind of started with a harder one here. So let's go ahead and do chromium chlorate. Chromium chlorate. Okay, so this is the positive ion, this is the negative ion. I'm going to go hunt for the symbol in charge for the chromium ion. And this is chromium 3 chlorate. All right, so we see that 3 in there. If you remember, this is because chromium is a transition metal, and apparently chromium has takes multiple charges, and you don't know which one to use until I tell you, and I told you it's chromium 3. So I'm going to go hunt for it on the positive ion list, and I find it. Chromium 3 is Cr3+. All right. Then I'm going to go find the chlorate ion in the negative column. And okay, if I look, I eventually will run into this thing, ClO3-. So this is a complicated ion. This is one of those polyatomic ions. It has its own chemical formula, and this group of atoms, for some reason, gets a negative charge. And so therefore will behave like a negative ion and will stick to positive things. So, okay, so the trick to remember here is that we're gonna treat this formula like one thing. And I'm gonna use corner symbolism around that formula. It is, this whole formula is a 1 negative ion, and chromium is a 3 positive ion. Now the formula, when these things bond together, they will bond together in such a way as to get charge equivalence. Right now, the charges are not equivalent. So what I'm gonna do is I gotta think about how many of these do I need to get to 3? Well, if I had 3 of these formulas and each one of them was negative, that would give me 3 negatives. And if I had 1 of these, that would be 3 positives. So I have achieved charge equivalence. This must therefore be the ratio we would find in nature. Cr ClO3 3. And hey, I've got a subscript of a subscript, and we talked about how to solve this issue with parentheses. So the formula should be Cr ClO3 3. And when you look on your solutions, it is. Okay, so let's do tin to permanganate. I guess I'll just do first, third, fifth, seventh, and so forth. Tin permanganate. Okay, so step 1, that's the positive ion. I'm going to go hunt for it in the positive ion list, and when I do, I find that tin is Sn, and it is a 2 positive. This is one of those elements that takes multiple charges, and therefore I have to tell you which one it is. And so it is a 2 positive because that's a Roman numeral 2. All right, permanganate, that's the negative ion. Okay, go hunt for permanganate and I find that it is MnO4 minus. Oh, this is a complicated ion. It's a polyatomic ion. These all got together and had enough electrons left over to have a negative charge. Therefore, it will stick to positive things and make ionic compounds. We know how to handle that. We've been taught how to handle that. So these are my ions. I like to circle this just because to remind you to treat it like that formula. We're treating like one object and we're using corner symbolism around that object. I've got the negative charge for that whole thing. All right, now when these things bond together, they will bond in such a way to get charge equivalence. Right now, we do not have charge equivalence because 2 plus is not the same equivalent to 1 negative. So if I were to double this, I would have 2 negatives. And have one of these, I would have 2 positives. So the ratio must be 10 permanganate. There's 2 of these permanganates for one of those 10s. Now I got a subscript of a subscript here. It's a parentheses, and I now have the formula. Next, we're going to do iron 3 phosphide. All right, step 1. That's the positive ion. I'm going to go hunt for it and on the list, and it is Fe. It's a transition metal, so it takes multiple charges. This is the 3 positive version of it. Phosphide. All right, well, I'll go hunt for phosphide. I find it. It is P3 minus. All right, it's just a simple ion. Now, I need to check charge equivalence. Oh, they are equivalent. I don't have to do any adjusting at all. Just one of each of these has the right amount of charges. So they must just pair up. That's it. The formula would be Fe. All right, that wasn't too bad. Okay, so just checking to see. Yep. Now, moving on, what are we going to do next? We're going to do rubidium hypochlorite. Rubidium hypochlorite. Step 1, rubidium is the positive ion. I go hunt for it. I find that it is Rb 1 plus. Okay, hypochlorite. Go hunt for hypochlorite. It is ClO minus. This is a complicated ion, polyatomic. It's made of 1 oxygen and 1 chlorine, and that pair of atoms has enough electrons to have an equivalent of a negative charge left over after everything moves and becomes a compound. So I'm going to treat this like one thing. And, all right, I have a charge in the upper right-hand corner of that one thing. All right, 1 minus, 1 plus. Hey, charges are equivalent. I don't have to do any adjustment. Just one of each is enough to have charge equivalence. So the formula should be RbClO. Sodium hydroxide. Okay. All right, sodium is the positive ion. I look it up, that's what I find it is. Hydroxide, Okay, so I go search for that and I find it is OH minus. Oh, that is a complicated ion made of one oxygen and one hydrogen, named hydroxide. All right, so let's treat this like one thing. So this charge in the upper right-hand corner stands for the charge of the overall group of atoms. All right, so now let's check charges. Charges are equivalent. I don't have to do any adjustment. One of each is good enough. So the formula will be NaOH. Moving on. Nickel hydrogen sulfate. All right, positive ion is nickel, nickel 2. All right, nickel's a transition metal, takes a variety of charges. The one we're talking about is the 2 positive, that's what that means. So I go, if I'm not sure about the symbol for nickel, turns out it's Ni. This tells you it's a 2 positive. What are the other ones? Nickel is also a 4 positive, apparently. So we're not talking about that one. All right, hydrogen sulfate. Go look that up. It is HSO4 minus. So this is a complex ion, complicated ion. It's polyatomic, many atoms. Apparently, if you stick an H and S and 4 O's together, they will bond. They will actually bond covalently, but there's enough electrons floating around to where they end up with a net negative charge on this group, and it behaves like a negative ion. Therefore, we're going to treat this like one thing, and in the upper right-hand corner of this one thing, we will put its overall charge, and down here is where we would write the ratio in a compound of this one thing. All right, so let's check for charge equivalence. This is 1 negative, this 2 positive, that is not equivalent, so we're going to have to adjust some ratios. If we had 2 of these and each one was a negative charge, we would have 2 negative charges. 1 of these is enough to have just 2 positive, so all we had to do was adjust the amount of this up in order to get our 2 negatives, and now charge is equivalent. So the formula must be NiHSO4 2, and we have a subscript of a subscript. That is the formula. All right, the next one. Manganese 2 oxide? Manganese 2 oxide. All right, so manganese is the positive ion. I'll go find the symbol for that. And it is a 2 positive manganese, and that makes sense because manganese is in that block of 10. It's a transition element, and those take multiple charges frequently. This is the 2 positive version of it. Oxide, okay, go hunt for oxide, find out that's just O2 minus. And it's just a simple single atom ion here. Charge equivalence, they are already equivalent. 1 of each is enough for them to match and have charge equivalence. So the formula will be tin cyanide is next. All right. Tin 2 cyanide. Tin 2, I'm going to go look that symbol up. It is SN2+. That's what the 2 means, the 2+ version. Cyanide. Cyanide is carbon and nitrogen 1 negative. So this is a polyatomic ion. If you take a carbon, stick it with a nitrogen, they will bond covalently and have enough electrons left over to have a net negative charge, and it will then therefore behave like an ion and go through ionic compounding, ionic bonding. And so, got my ions. Remember, we're going to treat this like one thing, and up here's its overall charge. Down here will be its overall ratio in the compound. We've got 2 positive charges, 1 negative. Those are not equivalent, so I'm going to need to double these to get 2 negative. So there must be 2 of these cyanides bonded to one of these tin 2s in order for charge equivalence to occur. Therefore, the formula will be tin cyanide with a 2. Now, I didn't talk about this, but I'm glad that when this comes up, we need parentheses around this too. Even though we do not have a subscript of a subscript, if we just leave the 2 dangling out there, that looks like it just applies to the nitrogen and not the carbon. But that's not what we mean. We need 2 of these overall ions. That's why I circle it. We need 2 of those cyanides. And so we're going to put parentheses around this so that we are properly communicating that that 2 applies to both atoms in this polyatomic ion. All right, so that is the formula. That's it. I did every other one, and hopefully that was helpful. See you next week.